I'm a research fellow in electricity markets at University College London, based here in the UK. I'm delighted to have been invited to this 19th edition of the Seoul International Conference on Electricity Markets. So today I'll give you an overview of UK experience with electricity markets and an introduction to the market design proposal, which myself and Professor Michael Grubb have been working on for the past few years. Michael is one of the leading energy economics and electricity market experts in the world, so I would urge you to follow his work. In regards to myself, as I say, I'm currently a research fellow at UCL. My background has been sort of 5 years in energy and electricity market design. I spent 3 years at Energy UK, the trade association and representation of the private energy sector in the UK, where I was focusing on low carbon electricity policy. And then I spent about just under 2 years at the Tony Blair Institute, focusing on net zero and energy research. So today I'll take you through 3 key parts of the presentation. So the first part will be some context around the electricity system in Great Britain and how it's changed over the last 10 to 20 years. The second part will look at decarbonising electricity in the UK and what needs to be done and by when. And then the third part will look in more detail at electricity market design. What are the issues with the current system and what do we think needs to be done to resolve those issues? So this slide here gives you an overview of the UK electricity generation mix of the last 20 years or so. So you can see the red line there around 2013, 2014 was the introduction of what we call EMR, electricity market reform in the UK. And this is the last major reform of electricity markets in the UK. It introduced 4 new elements to the UK market: the contracts for difference scheme, which offered competitively allocated fixed price contracts to renewable generators for generation. We had a new carbon price, which effectively made gas cheaper than coal to run and was a key driver of ensuring that coal was moved off the UK electricity system. As you can see to the right side of the graph, the black bars decreasing rapidly down to where we are today. Coal only produces around 2% of emissions, 2%, of electricity generation in the UK today. We also had the capacity market scheme, which offers a competitively allocated payment to power plants to be on the system for periods of high demand to ensure that the demand is always met and the system is secure. And finally, we had the emissions performance standard, which set emissions limit on power plants and was a regulation that also helped to reduce the amount of coal-fired power generation in the UK. So we've seen a rapid change, especially in the last 10 years or so, in the UK electricity system. Here we have two charts that show where the UK needs to go over the next 10 to 12 years or so. The target that the UK government has set is for a decarbonised electricity system by 2035. Electricity is also very important in the system because we expect electrification of other sectors to be a key element of decarbonising the whole UK economy by 2050. So currently in the UK, in terms of heating homes, 85% of the population, 85% of the 29 million homes across the UK heat their homes using natural gas boilers. We expect the vast majority of these heating systems to transition to electric heat pump systems over the next 10 to 20 to 30 years. On the vehicle side, obviously the majority of cars in the UK at the moment are petrol and diesel cars, but we are rapidly growing the number of electric vehicles in the UK, and we expect electric vehicles to be the dominant vehicle on the system sort of from 2035 beyond. In fact, the government does have a target and a regulation, which means fossil fuel and petrol vehicles will no longer be sold in the UK beyond 2030. So all of this means that there will be far more demand on the electricity system in the UK. We expect electricity capacity to need to at least double in the next 12 years to meet that demand. And this means huge increases in solar and offshore wind, as well as the introduction of new technologies such as gas with carbon capture and storage, and hydrogen, low carbon hydrogen fired generation. The right-hand chart is indicative generation mix from this capacity in 2035. We can see that the vast majority of electricity was coming from renewables and nuclear, the green and orange bars, and so there is still some unabated gas on the system, the grey bars at the bottom, but emissions from that is expected to be offset by the purple bars underneath the zero line, which will be negative emissions from bioenergy with carbon capture and storage. It's interesting that the UK expects to become to change from being a net importer of electricity to becoming a net exporter of electricity by 2035. And this is because of all that renewable capacity that will be built. The offshore wind, onshore wind and solar capacity means that certain times of the year, for potentially a lot of the year, the UK will be generating more electricity than is required, and we will therefore have excess electricity to sell to our neighbours, France, Germany, Belgium, Norway, all these countries that we have interconnectors with. So I think that is a high-level overview of the system as it stands. But what needs to be done in order to deliver that change between now and 2035? So there's three key areas to focus on. You may have heard them referred to in the past as the energy trilemma. So firstly, we must create an attractive investment environment to bring forward the billions of pounds of capital investment that will be needed to deliver the 100+ gigawatts of new generation capacity and storage. Supply chain investment and coordination will also be key to ensure that we have the capacity to build all of this brand new infrastructure across the UK. With all this new generation capacity that needs to come onto the system, there comes a challenge in moving that electricity around the country. So the second chart here to the bottom left shows how the electricity flows will change across the country between now and 2030. We will have far more renewable generation in the north of the UK, so off the coast of Scotland, far more demand in the southeast where the population is concentrated and people have electric vehicles and electric heating systems, and therefore we will have a need to move far more electricity across the UK, across the country from north to south, and as a result we will need far more transmission capacity and wires to carry all that power across the country to where it's needed. Currently, we have an issue in the UK where planning and consenting regulations are creating delays of up to 13 years for new transmission capacity. So there's a clear sort of administrative barrier that needs to be overcome there. Finally, looking towards the right of this slide, we can see that all of this work for net zero will only really be affordable if energy bills to the end consumer remain affordable. The chart shows historical energy bills up to Q1 in 2023, so this year to March 2023. And these projections are now out of date, but they show that wholesale prices rose to unprecedented highs in mid to late 2022 into early 2023. And we have now seen prices drop off a little bit more since then. But you can see just how desperate the picture is for households. Government has had to step in with support, and at one point this winter was paying for half of household energy bills. In fact, households were paying energy bills that were twice the pre-crisis level. And at the same time, government picked up a bill of around 40 billion supporting the remaining side of the bills there that you can see towards the end of 2022 and into 2023. So clearly this is not a sustainable solution in the long run. So moving on to electricity market design, what this means for electricity market design and the challenges that we are facing today. So this slide is designed to show the changing nature of the GB system. At the top left, we can see how the key characteristics of the system are changing as we move from a fossil fuel based system to one that will be dominated by renewables in the future. So for the fossil fuel technologies, we know that they are baseload technologies. They like to run most of the time. They're also flexible, what we would call dispatchable technologies, which means that you're able to turn them on and off to respond to changes in demand on the system. On the other side, the new technologies, wind and solar, are variable technologies. So they generate according to the weather conditions, the amount of sun, the amount of wind. They're also inflexible. We are not really able to turn these technologies on or off according to the demand on the system. The project cost profile I will come on to a little bit more detail below, but generally the costs are dominated by fuel costs for existing technologies, the gas and coal, whereas for new technologies, the overall project costs are dominated by capital costs, the actual construction of the power plant, because the fuel costs when the power plant is in operation are effectively zero, because the wind and sun are free resources. The role in the market is really interesting. So for gas and coal-fired power plants, they tend to operate at the margin of the market. You can see on the chart on the right-hand side, the dark bars, those are the high-cost technologies that are operating flexibly at the margin to meet demand at any one time. This means that they have very differentiated prices reflecting the variable costs on the system. In contrast, the new technologies, wind and solar, are price takers in the system. They will run whenever they're able to, whenever the wind is blowing, whenever the sun is shining. They are very low priced technologies and therefore will always be chosen before the fossil fuels. They require stable prices reflecting the capital repayments. So if we look below here to the two horizontal bars, we can see the fundamental differences between the old and new technologies. Namely, this is the proportion of capital expenditure to operational expenditure over the lifetime of the project. For the typical gas-fired power station, the bottom bar, the dominant fossil fuel technology in the GB system, capital costs typically contribute to less than 10% of the overall lifetime cost of the project. Whereas for the typical offshore wind project, the top bar here, the capital costs contribute to around 60% of overall lifetime cost of the project. Now, this has big implications for project risk and therefore a project's ability to raise capital and the associated cost of that capital. In short, the high capital costs, the high capex balance means that investors are in a more exposed position when investing in renewables projects. As a result, volatility is a risk to investment in these types of projects. The more uncertain the revenue stream, the higher the risk, the higher the interest rate applied to the capital, and therefore the higher overall project cost. Whereas if the revenue stream can be made more certain, investment risk falls, the associated interest on the capital loans also falls, and the overall project cost falls as a result. In summary, this means that revenue certainty is absolutely critical for renewable projects and any other project with a high capex balance. On the right, we have the merit order of the GB electricity system. On the y-axis is the price, and on the x-axis is generation capacity or the demand that needs to be met at any one moment on the system. So at any time, at any given moment in the system, to meet demand on the system operator will stack generation from the cheapest to the most expensive until demand is met. So we will move from the left-hand side of this chart over to the right-hand side. The power plant at the margin sets the market price for that period, and all of the generators receive that price. This is what we call a pay-as-clear, short-run marginal cost price system. This has worked fine in the past in the UK when fossil fuels were relatively dominant in the system, and they have pretty similar prices. However, as renewables become more dominant, and we see the fossil fuels shifted towards the right, what we now have is effectively a system of two prices. The very low short-run marginal cost price of renewables, due to the absence of fuel cost, as I said, the wind and sun are free resources, is very different from the high short-run marginal cost of fossil fuels. So in the short term, technologies on the left side here can earn a significant windfall if they are not on fixed priced government contracts. And this results in consumers overpaying for their energy. In the long run, as renewables become more dominant and are able to meet demand on their own without fossil fuels, the wholesale price will collapse towards zero, creating a significant long-term risk for investors in recouping their capital. We see that this situation shows that the marginal cost curve is already split, and therefore continuing to treat the two pools of generation as one is clearly unsustainable as we move towards the future system. As a result, we've been doing a lot of work and a lot of thinking around alternative market design options, and now I'll take you through where we've come to. So here is our lead option for wholesale market electricity design in the UK, the green power pool. Sorry, I just skipped 2 slides. So I'll now take you through this design starting at the top left. So qualifying green generators would hold a fixed price contract similar to CFDs to sell their power to the green power pool. At the top right, the remaining generators, the other generators in the market, will continue to sell their power as they do today into the wholesale market at the short-run marginal cost price. This is effectively the split that we already have in the current market, but it just treats the two technologies separately at the starting point. At times when the green power pool does not meet demand, the green power pool will buy additional power from the wholesale market. These are the two lines that you can see running across the top of the middle boxes. And they will buy that additional power to top up supply to meet demand. Whereas at times in the future, where there may be more generation, renewable generation on the system, and the green power pool is more than able to meet demand, and there is excess power in the green power pool, the green power pool would then sell this excess electricity to the wholesale market at the market clearing price, so a relatively cheap price. And this offers cheap electricity for storage and other flexible assets. Looking towards the bottom, on the left, the GPP would have two broad groups of customers: non-residential large energy users such as industry, and residential customers, household customers who would receive their GPP, the green power pool power, through a franchise supplier. Both of these customers would receive a two-tiered energy bill. The first tier would provide the assured price of electricity from the green power pool, the price being determined by the average cost of the fixed price contracts within the green power pool. The second tier would be the marginal cost of electricity from the wholesale market required from the GPP when supply does not meet demand. We believe that this structure would maintain efficient short-run marginal cost pricing on non-green generators, while introducing long-run marginal cost pricing for green generators. This aligns the pricing mechanism to the financial characteristics of the two technology groups and delivers certainty for both investors, whilst also delivering accuracy of prices for customers. We believe this is the fairest way forward for customers, and it also gives confidence to the market to invest in more green and renewable technology. Finally, just a quick case study of something that could be done with green power pool supply. So with a clear stream of low-cost renewable electricity, governments will have the option to target that supply at priority customers. In GB, Great Britain, we have identified steel plants as a clear example of a possible priority beneficiary group for GPP supply. The reasons we identify steel as being important is that it is a strategically important sector to the UK. It is also a sector with high energy usage and emissions, and it faces the most immediate threat to international competitiveness. So access to low-cost, reliable, priced, and clean electricity from a green power pool would make the steel sector more competitive. It would provide a long-term certainty of electricity prices, which in turn would give steel power plants confidence to invest in electrifying their operations, so switching from blast furnaces to electric arc furnaces. And of course, that would lead to a rapid reduction in emissions from the steel sector. We've heard recent reports that the UK government has been offering 600 million to the UK's 2 blast furnace sites to convert to electric arc furnaces, but that would require billions of co-investment from the companies themselves. And at the moment, with the uncertainty around electricity prices, they just do not seem to be in a position to want to make that investment. So having this long-term certainty over electricity prices could really help provide an incentive for that switch from blast furnace to electric arc furnace. So that brings me to the end of my presentation today. Thank you very much for listening, and please do get in touch if you have any questions. I hope you do enjoy the rest of the conference today. Thank you for your time.
네, 좋은 강연 해주신 런던.
Thank you very much for the wonderful presentation. Now we are going to have the Q&A session. Actually, because he cannot attend this conference, he sent us a video with pre-limited questions. Let's meet him together.
Hello and thank you. I'm very glad to join this Q&A session. So thank you for the first question. So is the green power pool an idea in the UK's REMA, or Review of Electricity Market Arrangements process, or the EU's reform of electricity market design? So it's a good question, and it betrays very good knowledge of the developments of UK energy and electricity policy. So for those that are not aware, the Review of Electricity Market Arrangements, or REMA as we refer to it, is the first major review of electricity market arrangements in the UK since 2013, and that electricity market reform process that I mentioned in one of the first slides in my presentation. So it's quite an exciting reform. It's a big opportunity for change in the UK system. And I think it's actually an example that hopefully other countries around the world will be able to learn a lot from, because we really are stepping into the unknown here. The Green Power Pool proposal is indeed one of the formal options being considered as part of that process. The next step in that process will be a second consultation from government, which we expect to be released in November this year. At this point, government aims to further narrow down the options for reform and consult on the various benefits and drawbacks of the remaining options. Of course, we're in regular discussion with government officials, and we hope that the Green Power Pool continues through this next stage of consultation. We really do think that we need to see decoupling of gas and electricity prices. We see this as crucial in this period of elevated prices, and a route to protecting customers from future energy price shocks. So, there's benefits both on the supply side in terms of renewable generation and expanding investment in renewable generation. But right now, and importantly politically, it's very important to ensure that bills are affordable in the near term and the long term for consumers. At the European level, there's certainly awareness of the Green Power Pool proposal. We've done several presentations across the EU on this topic, but it's not formally being considered as an option for near-term implementation. I think the reason for that is that the EU Commission progressed quite quickly earlier this year with their own electricity market reform process. It was implemented, as I say, quite quickly at the start of the year, but the reason it was quick is that the reforms that were implemented were quite modest. So we're talking sort of amendments to support more PPAs, amendments and directives to member countries to engage in more contracts for difference schemes. So we're not aware at the moment of considerations of more formal and fundamental reform options, and that is where the GPP, the Green Power Pool, would typically be included under consideration. So the second question that's come through: if a Green Power Pool is on the move, which organisation will operate it? Does National Grid Electricity System Operator, should that have responsibility of Green Power Pool operation? I think this is a great question. Really gets to the heart of one of the key issues with the Green Power Pool. So I'd say at present, we're simply referring to the organisation as the Green Power Pool operator. We haven't yet formally set out our preference as to whether this would be undertaken by an existing participant in the market or a new body. However, I think intriguingly, at the moment, we're also going through a process of transitioning from the current National Grid Electricity System Operator to a fully independent future system operator, which is expected to come into place sometime next year. This new independent future system operator will have a mandate to play a more active role in both the design and operation of the future system. And I think at present, this would appear to be the most natural operator for the Green Power Pool in future. I think one more question has come through. So we're looking at the current status of the Green Power Pool and the future plan. So I think the current status really in terms of the government's REMA process is what I'd explained in response to the first question. But in terms of our own work, we are currently finalizing a paper which is exploring how a Green Power Pool would work alongside retail tariff reform options to deliver lower and more stable bills for consumers in both the near term and the long term. The long term is crucial because a lot of the focus at the moment is on the near term, but we need to make sure that bills are affordable for consumers all the way through this transition. Otherwise, we will undermine all the effort and investment that is required in this transition. So this paper will be published on the 14th of September. So please do keep an eye out for that on the website, and obviously on Twitter we'll be posting threads that summarize the reports. And beyond that point, I think the next big challenge for us at UCL is we're hoping to launch a new centre for net zero electricity market design, which will be focused and headquartered at UCL. So at a very high level, the idea is to create dedicated academic resource that will, for the first few years, help to inform the government REMA process before expanding more widely and more broadly on UK and European electricity market reforms that will be required for net zero. I think it's important to say that we do not see electricity market reform as sort of a one-off short-term process. This is something that's going to have to continue to develop over time as we transition to net zero and the system, the requirements of the system change, and the requirements of the investors and consumers on the system change. So it'll be we see it as a quite gradual process with several sort of moments of reform over the next 5 to 10 years even. The centre will provide independent analysis and scrutiny of the various options that the UK government is considering in REMA, as well as exploring more novel policy options that aren't necessarily being considered in this reform process. Of course, the Green Power Pool will be one of the options that we'll be focusing some of the research on, and we'd like to develop that more. And obviously that is dependent on its progress through the government's current consultation. But we also intend to focus more broadly on the range of reform options that are being considered in REMA and other options beyond. Just for information, it will be co-funded, the centre, by UCL and industry, with direction provided by an advisory board, which will have industry players, a representative from the Government Department for Energy Security Net Zero, the government regulator, Ofgem, and National Grid, ESO, or the future system operator when it becomes that, and we'll obviously have it chaired by an independent expert. So if anyone is interested in that and would like to keep up to date with the progress of that centre, please do get in touch through the contact details provided on my presentation. Thank you.